In 3-2, we're going to focus on parallel lines and transversals, and then the angles that are created by those. So our learning target, I can calculate or determine the angle measure for any of these special angles that are created. So here's our picture. Remember, there's all kinds of special angles that are generated in this picture. Just to review back from 3-1, there's the alternate interior, same side interior. There's the corresponding. There's also alternate exterior angles here. So if you look at these angles, now one thing I want to point out, see this little symbol right here? This means that these two lines are parallel to each other. So one of the key pieces of information in this section is that the transversal cuts parallel lines. So that's a key piece of information because if those two lines were not parallel, then these special angle relationships would not be generated. So looking at these angles, there's a lot of assumptions that I can kind of, a lot of um, I guess, conclusions that I can draw just by looking at these angles. For instance, if I look at 1 and 5, angle 1 and angle 5, I can basically come to a conclusion that it looks like those two angles are possibly congruent to each other. So that's what the focus is on in this section. It's those special angles and then the relationships that are generated by those special angles. So the first one, corresponding angles. Again, corresponding angles are the ones where if I was to chop this right here and then take these and put them on top of these, I would have angle 1 and angle 5 would match up to each other. 6 and 2 would match up to each other. 7 and 3, 8 and 4. Hopefully, by looking at that picture, you can come to the conclusion that all corresponding angles are congruent. All corresponding angles are congruent to each other. Every corresponding angle is congruent to as long as the two lines are parallel, then all corresponding angles are congruent to each other. Now, what about same side interior angles? If I go back to same side interior angles, so that'd be like 3 and 5. No, 3 and 5. I know that 5 is congruent to 1. So if 5 is congruent to 1, that means that 3 would have to be, for example, let's say that this was 100 degrees. 3 would have to be 80 degrees, which means 5 would have to be 100 degrees. And that's because 5 and 1 are corresponding, so therefore they're congruent. So 3 and 5, the conclusion that I can draw about angle 3 and angle 5 is that they are always going to be supplementary. Supplementary. So anytime you have same side interior angles, those two angles will always be supplementary to each other. In other words, they will always add up to 180 degrees. Alternate interior angles. If I go back and take a look at my alternate interior angles, my alternate interior angles would be like angle 5 and angle 4. They have to be in between the two lines and they have to be on opposite sides of the transversal. So 5 and 4, if I know that 5 and 3 are supplementary, I can therefore come to the conclusion that 5 and 4 have to be congruent to each other. So anytime I have alternate interior angles, those two angles will always be congruent to each other as long as the two lines are parallel. And we can prove this to be true by taking all these angles and matching them up and measuring them out, and we can prove that each one of these is true. Alternate exterior angles. So alternate exterior angles is when they are on the outside of the two parallel lines. So alternate exterior. Exterior means that they have to be out here and out here. So they have to be outside the two lines. Now, alternate means they have to be on opposite sides of the transversal. So that would be like angle 8 and angle 1, or angle 7 and angle 2. So if I analyze these a little bit, I know that 8 and 4 are congruent, and I know that 4 and 1 are vertical. Well, that means angle 1 would have to be congruent to angle 8. And that's because vertical angles are congruent. So I know that 4 and 1 are congruent, so therefore, so it's just kind of that whole logical thought process that leads us to this final conclusion that alternate exterior angles are congruent. All right, now these four statements here, since we can actually go through and prove them, we can prove them to be true. Since we can prove them to be true, we can state them as theorems. So remember the definition of a theorem, anything that can be proven to be true. So we can state these as theorems now. So our theorems here that we just stated on the previous slide, our four theorems that we just stated on the previous slide. If two lines are parallel, then the corresponding angles are congruent. There's our first theorem. Our second theorem, if two lines are parallel, then alternate interior angles are congruent. There's our second theorem. Our third one, if two lines are parallel, then alternate exterior angles are congruent. And then our last one, if two lines are parallel, then consecutive interior angles are supplementary. So three of them are congruent, and then one is supplementary. All right, so there's our first four theorems. You're going to have to be able to basically just write these out and say, hey, you know what? If two lines are parallel, then I know that their corresponding angles are congruent. So you basically just kind of state that fact, because geometry is a lot about stating your logic and your understanding of that thought process that led you to that final conclusion. All right, and that can, oh, I thought that was the end. I guess I have a couple examples here real quick. Let's go through those. The measure of three of the numbered angles is 55. Identify those angles and explain your reasoning. Well, if this one up here is 55, I know that angle 3 is 55. And the reason I can state that is because vertical angles are congruent. Now, 3 and 7 are corresponding angles. I can state that 3 and 7, I can state that angle 7 is 55 degrees, and that's because corresponding angles are congruent. I can also state that angle 6 is 55 degrees, and there's two ways that I can state that. Or three ways, I can state because of vertical angles are congruent, I can state because alternate interior angles are congruent, or I can state because of corresponding angles are congruent. So there's several different ways I could state that one. All right, now how are we going to use this to help us blend in the algebra from last year? Taking a look at this one here, now I'm starting to blend in some of the algebra from last year that we did. So if I analyze this a little bit, I know that these are corresponding angles. And I know that corresponding angles are congruent. So if parallel lines corresponding angles congruent. Well, congruency means that they equal each other. So if they're congruent, I know that these two things are equal. So since they are equal, I can go ahead and set them equal to each other and then solve it. So if I add 30 to both sides, I find out that x, in this situation, x would have to equal 165. So that's how we're going to start to blend in some of the algebra then from last year that we did. Find the value of x here. So if two lines are parallel, now I would have to know. So let me put some little marks on there so that you know for a fact that those two lines are parallel. If they're parallel, then I know that those two angles that are shown there are, this one here is congruent to this one. So if these two are congruent, then I know that these two are supplementary. Okay, since I know that those alternate interior angles are congruent to each other, then that logical thought process leads me to the fact that these two angles have to add up to 180. So these two angles right here have to add up to 180 degrees. All right. Now I just followed that one thought process. You could have also followed the fact that this angle is congruent to this angle up here. And now looking at those, they form a straight line. So since they form a straight angle, I know that they both of them add up to 180. So since they both add up to 180, we can go ahead and set this up. So I subtract 120 from both sides, and I find out that x is equal to 60. So our x in this situation would be equal to 60. All right, now that completes everything for this section. Again, in this section, we focused on parallel lines cut by a transversal and then the special angles that are created. We focused on those four theorems, those things that are proven to be true. And then we also took a look at the algebra piece that kind of blends in with this geometry, and then how we find those angle measurements.